So today I've got this little Vizio 32-inch. It is a model E320-A0, and I'm not getting any response out of the power button on the side of the set or the remote. It won't turn on. So let's do a couple checks real quick. Let's make sure that the standby voltage is getting from the power supply to the main board, and then we'll investigate repairing this little set. Okay, so on this one, the power supply, really straightforward. Not a heck of a lot to it. As you can see, there's only the AC plug down here on the bottom, and there's one output jack, and that's it. So the first two pins on the output jack are both ground, so we should have 0 volts. And then the next two pins are a output voltage. Let me turn on the power supply, and we get 24 volts. So that tells me that we've got everything working. They're both 24 volts. Not a heck of a lot more you can do with this. This one does not even have a power on-off command or a backlight control on the power supply. Everything on this set is controlled from the main board. Alright, so just a couple quick things to look for is, of course, I know I've got my 24 volts over here at the power coming from the power supply to the main board. So I want to check this little connector up in the upper right hand corner, and it's got 4 pins on it. And what I want to do is I'm just going to put my probe on there and press the power button, and there it is right there. Make sure I see a change going into it. I want to make sure I don't have any other buttons stuck on here. So I've got 5 volts and I've got 0. Let's press a couple of the buttons and see if we get a response from one of those switches. That one might be ground. This one is another one that's 0, and I get a couple responses on a couple other switches, so I'm pretty sure that that's working. And then we got this last pin, which is the other switches. It's a resistance ladder network, and that just means that one switch will give you one particular voltage output, and another switch may give you a different 0.465. This one gives you 1.0. And we got a couple other ones, 1.7, 1.0. And that tells the microprocessor which button you have indeed pressed. There's little regulators all over the board on this one, just like the other videos. You can check on the tabs on these to make sure you've got some common voltages. Let's see what we get on some of these guys here, if we can even probe them. Some of these won't be active until the set's actually on, then the other ones will be when the set is off. So 1.5 volts, that's one of the microprocessor core voltages. 3.3 volts, that's the main voltage the micro runs on. So let's come over here to the eeprom. I had some problems with some eeproms, which is why I'm going right to this. I just want to make sure that I get 3.3 volts on the eeprom. And then we should have a couple other pins that just have some minute voltage as it reads and writes data. So I've got some with 3.3. I had one that had 0.2 volts, and it's kind of changing up and down, so it's trying to do something. Next thing I'm going to do is I'm just going to simply replace this eeprom and see what kind of results we get from there. And now here's the eeprom I've got, and it's still in the ESD protective bag here. Maybe hard to see because it's very shiny. Anyhow, the reason I suspect this is because I've had quite a number of these E320 type sets, the really economy Vizio sets, I believe that's what the E stands for, that have had bad EPROMs. It was really prevalent a couple years ago, and we actually purchased a EEPROM reader writer, and one of my YouTube followers determined that you could heat the EEPROM up and you could get it to work correctly. So what I would do is take it off the board, heat it up, read the data out of it, then write it into a good fresh EEPROM. All this was very inexpensive. The EEPROM reader writer I think was about $30 on eBay, and the chips from DigiKey or Mauser I believe were under $3 a piece. So it was very cost effective. When we were seeing these sets coming in at the rate of probably 1 or 2 a week, it was quite a good profit margin on something like that, when you could just write the data to an EEPROM, solder to the board, and you're ready to go. Anyhow, here is the EEPROM on this set. Let me try to zoom in here and see if we can get some kind of a view on it. And I'm just going to go ahead and desolder it, and I'm just going to use the flow solder method. I'm just going to heat up all 8 pins simultaneously with a big ball of solder, and just lift it off the board, clean it off, and tack the new one down. So here we go. So firstly, I've got my Kester Flux pin. This has been pretty good. I've used it on other videos before. And I'm just going to apply a little bit of flux on each side of the eeprom. That makes the solder stick a little bit better and doesn't have the jagged peaks. It helps it melt at a lower temperature and keeps it more confined to the pads. Okay, hopefully I can do this with the camera without making too much of a terrible mess. So I'm just going to add some solder to one side of it. I'm going to add fresh solder to the other side of it. Luckily there's no little chip components nearby. That's kind of a concern in some cases. Now always make sure that you know what side is what, where pin 1 is. In this case it's on this far corner. So I'm just going to heat it up a little bit. Heat up the other side, and it should just lift right off the board. Sometimes you can just scoot it to a little out of the way place on the board. And now to prep the pads, you can either desolder it. These actually look really good. If you just take a ball of solder and go across them, it kind of cleans them and preps them. It gets them preloaded with solder and ready to go. So let me get the new chip placed on the board here and ready to go. Alright, this one ought to be cool enough to move out of the way. And I've got my new chip. I'm just going to set it on here. Next, before I even tack it, I'm just going to hit the pins with the flux. Once again, helps the solder to stick a little bit better. Make sure your tip is fairly clean. Now it's going to be very hard to do this. I know my finger's going to get away in the way for just a moment. So I'm just going to tack the first pin. And I'm going to try to use the dental pick to move it to the rest. There, it's lined up. I'm just going to apply a little bit of downward pressure to it. And I'm just going to heat these pins up. It's kind of hard to see on the camera, but the solder actually just takes to the pin. The flux actually helps the solder wick up the pin of the chip. While applying a little bit of downward force, I'm just going to go ahead and resolder the other pins. Just as easy as that. Now I'm going to go ahead and clean the excess flux off of the board. Alright, now for that I've just got a little bit of acetone. Probably not be able to see it too well in the camera, but it's a very small bottle of acetone and a little acid brush. I found it works very nicely to clean up this kind of flux. It cleans off the rosin as well. So what I do is I just dab it in the acetone and rub it on the board, and I use the wicking of the actual bristles to kind of suck it off the board when I'm done. And then off camera you can't see it, but what I'm doing is taking it and I'm flinging the excess contaminated acetone off of the bristles so it'll absorb for the next round. Okay, so let's see what we get at this point. Okay, so I've got my new eeprom in here. I've got the power turned on, and what I'm looking at right here is the LED output. There's only one single plug on the set that drives the LEDs in this panel, and so it has a constant 24 volts on it. And I'm going to look at the return line on that. I'm going to hit the power button. One thing you can see right off the bat is I've got my little logo light popping on here. If you can see through the cutouts in the back of the TV, you can see that the LED has lit up, and I'm getting a return voltage as it's dimming the LED back. So pretty happy about that. Let's go ahead and stand the set up and take a quick peek at it. And then we'll do a real quick rundown on the voltages on the main board in case you're having another problem. Okay, so here it is from the front of the set with the power button. We should get a small splash of the Vizio logo. And I don't have any channels programmed. I don't even know what input this is on because it's a brand new eeprom. It just tells me no channels in the channel list. So we'll just hit the menu, bring up a menu, make sure it's working. I'm pretty happy that that's going to take care of it. Let's go ahead and make some voltage measurements for you now. Okay, so let's take a look real quick. First off, these two coils coming in here, we should see about the 24 volts on each one of those. And then we've got a FET right here, so let's take a look at the 3 pins there, 5.3. We've got 24 volts. And we've got 0 here. This little regulator right here, let's take a quick peek. 0.2, 15, and 2.3. We've got a couple other coils up here. We'll take a quick peek at those and see what we've got. So we've got 5 volts. We've got 12. It should be the same on the other side. And remember, if you don't have a good voltmeter that has good true RMS ranging, you may get the wrong voltage when you're on the pulse side. The meter has to average it out to show you the good, accurate, true voltage. You can look, if you see the bar graph on this one, it's kind of jumping around because it's trying to display that change very quickly. We've got another coil here. We'll take a look. 3.3. If I can get the probe on it, 3.3. Another one right here. And we've got 1.2. We've already checked this little regulator. 1.5 on the output. The adjustment pin has got a 1/4 volt, so that's a 1.2 volt regulator plus the it's 1.2 volts plus the 0.25, which gives us about 1.5 volts. And the input pin has 3.3 volts on it. Little regulator down here on the bottom. We've got 2 volts on the adjust, 3.3, and 5 volts on the input. So if you take that 1.2 volts, add it to approximately 1.25 plus 2, you get approximately the 3.3. Give or take, they're not 100% accurate. They're very close though. The rule of thumb pretty much is anytime you see the input and you add that voltage, such as on this one, it's got 1.2, the input pin, or the adjustment pin, I'm sorry, is grounded. The output is 1.2, and the input pin is going to be higher, 3.3. These 4 coils are the audio output circuit, and we should see about half VCC. So if it regulates it down to 12 volts, we should see about 6 on each pin. So the input voltage to the audio chip should be around 12 volts. We looked here at the keypad control already. The only other thing I can find is the remote receiver very quickly. Now the remote control receiver is going to be on this connector right here. This supplies the voltage to the infrared receiver as well as the little power LED, the little white LED in the front of the set. And let's just look at all the pins very quick without pressing any remote buttons. So effectively 5 volts, 0, 2.4, 3.3, and 3.3. So more likely than not, these 3 pins right here are the remote control receiver. 2 or 3 of these are the front panel LED. I'm not sure what the third one is, unless this set actually has 3D. It may. So let's take a look at pin 1 while we press a button on the remote control. You can see that flutters around. That tells me the remote control receiver is indeed working correctly. As I press the button, it does cause that 4.963 to drop to 4.962, and then the third pin is ground. Okay, so hope you enjoyed this little video on this Vizio replacing the eeprom to correct the no power dead set situation. Once again, the model on this one is an E320-A0 or A0 as the case may be. Appreciate your views, your comments, your support. Hopefully we can get some more videos up very soon. With your help, we can keep these things out of the landfill, out of the recycle bin. Remember, you can follow me on Twitter at NorCal715. Everybody have a great day.